So today we are doing medium problem 1461. Check if a string contains all binary codes of size k as a substring, otherwise return false. So length of string is this, and this is k, and I mean, you know, we could solve the problem in like what, oh something, OK squared, just cut out each substring, right? But we can, or nk, where n is length of s, but we can do better. Since k is up to 20, we could use a bit mask, right? So first we build bit mask of this, and then what we do is we shift as this and modulo by whatever mask which has k1s, right? So that we erase this other value. And again we shift, so we would get 0, 1, 0. We add 1, and I mean we don't have to subtract that, but that's okay. So, and this way we do it in ON. Not really, because there is what, 2 to k masks, so we could use like extra memory. Since each mask is just a number, we could have an array of size 2 to k, and at each position it will be 1, 0 if we have already seen it. And now if we have a mask, we check if it's 1, right? If it's not 1, then we set it to 1, and we increase count by 1, and in the end if count is 2 to k, then we are done. So we need to grab the size, we need to total, and then we need to have count 1 to k, and then we need to do mask is 1 to k minus 1, and then we do this, and then we need to have like current, right? So let's do total current, and then we want to do current shift by 1 if si1 current plus equals 1, if I minus k, then if current larger than or equal to let's do like m is 1 to k, this will be m, and if we are larger than m, then current minus equals m. That's basically modulo. And then we have the mask, so if count current is 0 or half or like seen or something, not seen, and then we just return if it's equal to m, non-iterable object. Great. That's true, because we have not seen 0, 0, so what the hell? Print current. If like that should work, okay. Because I was doing it for like, first I loaded first character, then 0, then we have 1, then we have 3, then we have 2, so it coincidentally worked out. Not the fastest. Not as fast as I expected, to be honest. Any way to make this faster? Let's see if that helps with anything. It's 227. Okay, it doesn't. Who cares? Okay, so let's do like space O2 to K. Okay, so how would we optimize it? I mean, we still have to know which we have seen and which we have not, so putting all substrings of size K into a hash set would take O n K squared, which is too slow. Instead, since K is quite small, less than or equal to 20, we could store each substring as a mask, which is just a base 10 number. First, make up the mask, the first mask, and then as we move to characters K plus 1 n, we first have to add the new character if it's 1, which we can do by setting mask times 2 plus 1, which is equal to mask 1 plus 1, right? First, shift the mask to the left to make space for the potential one. New, we add 1 if there is 1, and if we are on character K plus 1, character on the it character such that less than or equal to I, we have to remove the I minus k character, which we can simply do by subtracting 2 to k if is 2 to k. Essentially we remove MSB if its position is k plus 1. This way we do O1 work per character. To know how many masks we have seen, we can use an array of size. We use an array of size 2 to k, where visited mask true means we have seen that mask. If we have not seen the current mask, we increase the total mask count seen and we update the visited array. Okay, finally, if at the end we have counted to the listing masks, we return true. And since we do O1 work per character O1, O2 to K, since we are using, since that is the size of the. Okay, not horrific, quite simple actually, but I didn't want to bore you with another hard struggle, so see you tomorrow, bye.